Okay, so next problem, vector addition. So this is quite equivalent to the old problem where we now need to write a function add on the vector. It's given another vector and then it adds the two vectors together. So that means that just add the x coordinates with x coordinates and the y coordinates with the y coordinates. We can see from the problem description that this should return a new vector with the updated x and y coordinates. Okay, so I'm just going to copy this example. This should return a new vector with coordinates 5 and 4 and 6, 1 plus 3 and 2 plus 4. That gives the n coordinates. So we can just confirm that our code works when we are done. So I'm going to copy paste that in here. And then I'm going to print out the new coordinates of v3. v3 is the sum. Like this, because it needs to be a vector, so it needs to have an x and a y. So this function should be called add. So I'm just going to add a add method. Let's remove that stuff. And then let's write the function add. It needs to take itself as an input argument, so I can access to the x and y of the vector v1. And then we need to take the other vector, and I'm going to call it w. And then let's insert a breakpoint here on an empty line. So now when I call the function, it defines this vector, it defines this vector, and then it reaches this line. And remember that what this line effectively does is that it calls the add method with these two input arguments behind the scenes. So self will be equal to v1 and w will be equal to v2. I think I pointed to the wrong method. Self will be equal to v1 and w will be equal to v2. So that's what this will result to behind the scenes. And we can confirm that by doing self.x, and it should be 1, and self.y should be equal to 2. And let's just do w.x, it's 3 here, and w.y is 4. No surprise there. Okay, so what should be the x and the y coordinate of the new vector? Well, it should just be self.x plus v.x, right? That's the x coordinates. And the y coordinates is self.y plus v.y. And then we need to create a new vector with these coordinates. But we already know how to create a new vector with new coordinates. We just call the vector initializer. So we can just do it in one line like this and return it. Let's just confirm that this new vector actually ends up with the right endpoints. So we can call that for u maybe. And u has the right endpoints, namely 4 and 6, which is the sum of these two numbers and the sum of these two numbers. So that's what we return here. And I remove the breakpoint, I stop the debugger. And we can confirm that that actually seems to do what we intended to do. Let's just run the test. Did I even remember to run the test before? I can't remember. That was a grave mistake that we will solve now. Oh, please work. Please work. Run. Works. And it works. Maybe this one. We also implemented that. It looks like we are almost done. Maybe we are done. Let's see. We are done. Okay. So you need to implement a dot product function. I'll not spoil it completely, but this is a function where you can maybe be a little bit inspired by what the add or the scale method does. It's not that different. It just needs to return something slightly different that is actually quite easy to compute. And then there's a little bit of an error here. That's probably going to be fixed before tomorrow. Okay, so good luck with this this exercise, and good luck with the hand and the exercises tomorrow.